Welcome to The Explainer. Today, we're diving into what might just be the most powerful and strategic partnership shaping our future, the brand new relationship between artificial intelligence and nuclear energy.
Okay, let's kick things off with a number, a really, really big number. By 2030, the International Energy Agency figures that data centers, completely supercharged by AI, are going to be chewing through this much electricity every single year.
I mean, just to put that in perspective, that's more than Japan uses, the entire country. So yeah, that begs a pretty huge question. And finding the answer is forcing a massive strategic pivot. It's creating a partnership that could literally define the next tech revolution.
Now, don't think of this as just a simple transaction. It's way more than that. It's a virtuous cycle. You see, AI's insatiable demand for clean, reliable power is turbocharging the nuclear industry. And in return, AI is making nuclear faster, safer, and way more efficient. The growth of one is now directly accelerating the growth of the other.
Okay, so how does this actually work? Well, the first part of this revolution isn't even happening in the physical world. Nope, it's all starting in the digital one.
And right at the heart of this whole digital shift is this incredible concept called the digital twin. Now listen, this is not just some fancy 3D model. We're talking about a living, breathing, virtual copy of a real-world nuclear reactor, constantly fed with real-time data.
And the advantages here, they are just profound. I mean, just imagine being able to build and test a multi-billion-dollar reactor entirely in the virtual world first. You can slash design times, you can show regulators exactly how it's going to work to smooth out that painful licensing process. You can even run simulations that predict when a specific part might fail, years into the future. It's really the very first step toward creating truly autonomous nuclear plants.
And look, this is not some far-off theory. The industry is moving incredibly fast. You've got national labs teaming up with big tech like Amazon Web Services to get these digital twins up on the cloud. You have companies like Hitachi creating entire metaverse platforms to manage their plants. And we're even seeing this tech being used for the ultimate prize in clean energy, nuclear fusion. All right, so that's the virtual side. But what happens when these digital innovations cross over into the physical world? Let's take a look at how AI and robotics are, actually getting their hands dirty.
Let's talk money. This number? That's the Series A funding that an AI startup called Nuclean raised in a single round back in September of 2025.
So why the huge investment? Well, it's because Nuclean's AI is solving a massive headache for the existing nuclear fleet. Their platform can read and understand millions of pages of dense technical documents. It automates safety reports and compliance checks that used to take teams of engineers weeks or even months to finish.
And then in the physical world, you've got AI-powered robots tackling one of the industry's absolute toughest jobs, cleaning up old radioactive waste. A perfect example is the UK's AutoSAS project. They're using autonomous robots to sort through this waste. It's a job that's not only way safer and more accurate than sending people in, but it also saves millions of dollars.
Now, what's really interesting here is the deployment plan. Notice that? They have a cautious 2-year testing phase in a completely safe, non-radioactive environment first. This perfectly illustrates the nuclear industry's #1 absolute priority, safety above everything else.
Okay, but this revolution isn't just about smart software and robots. It's about fundamentally changing how we physically build nuclear reactors, right from the ground up. So, here's the crucial point. Technologies like large-scale 3D printing are finally solving the biggest historical problem for nuclear power, which is those incredibly long and expensive construction projects. This quote, from a report on Kairos Power's work, shows just how dramatic that speed-up can be. From weeks to days. That's a game changer. And this shows that additive manufacturing isn't just some niche experiment anymore. It's being adopted all across the entire nuclear ecosystem. From printing molds for concrete shielding, to making complex fuel parts, to even creating obsolete spare parts to keep older plants running safely. It's everywhere.
But technology alone, no matter how cool it is, isn't enough to spark a full-on renaissance. It's being supercharged by massive shifts in global policy, in investment, and in some really key strategic alliances.
The single most significant development here has got to be the creation of the Atlantic Partnership for Advanced Nuclear Energy. This is a landmark agreement between the United Kingdom and the United States.
So what does it do? Well, its main goal is to attack the biggest hurdle for new nuclear, that long, painful regulatory approval time. The goal is to cut it in half. By getting US and UK regulators to recognize each other's safety reviews, they can potentially take a 5-year process and shrink it down to just 2. For any company trying to build these things, that is a massive, massive de-risking event.
But make no mistake, this is also a major geopolitical move. A core objective is to build a secure nuclear supply chain among allies, with the very explicit goal of ending all dependence on Russian nuclear fuel by 2028. This is all about energy security.
So with all this incredible momentum, you've got new tech, new money, new policy. It all sounds great. So what could possibly slow it down? What are the risks here?
Well, there are still 3 major hurdles. Regulators are still trying to figure out how to certify all these complex AI systems. The economics of new reactors still need to be proven out at scale, but as you can see, the biggest challenge of all, the highest bar, is the supply chain. And the most critical bottleneck inside that supply chain comes down to one thing, a specific new type of fuel called HALEU. It's the fuel that most of these advanced reactor designs absolutely need to operate, and right now, the Western world simply isn't producing enough of it. The entire future of this industry could literally hinge on solving this one single problem.
So, the convergence is here. It's happening. We have this powerful co-evolutionary race between the growth of digital intelligence and our ability to power it. The question is no longer if these two forces are linked, but whether the energy side of the equation can innovate fast enough to keep up with the demand.